In the vast expanse of our cosmic backyard, there's a world that seems to have leapt straight from the pages of a science fiction novel. But this isn't fiction at all. This is Titan, the mysterious giant moon orbiting Saturn, and it's one of the most extraordinary places we've ever discovered. Picture yourself standing on its surface. Above you, orange-tinted clouds drift lazily across a hazy sky. But what makes this world truly remarkable is what falls from those clouds. Instead of water droplets, it rains liquid hydrocarbons, essentially gasoline, creating rivers and lakes filled with liquid methane that shimmer under the dim sunlight that manages to pierce through the thick atmosphere. This alien landscape, as bizarre as it might sound, has captured the imagination of scientists worldwide. Why? Because Titan presents us with an incredible possibility. It might be home to life forms completely different from anything we've ever encountered on Earth. Think about it. While Earth's life is based on water, Titan could harbor creatures that use liquid methane as their life-giving substance. The story of Titan begins in the year 1655, when Dutch astronomer Cassini Huygens first spotted this remarkable moon through his telescope. Little did he know that his discovery would lead us to one of the most promising locations in our search for life beyond Earth. In fact, Titan is the only moon in our entire solar system that has a dense atmosphere, even denser than Earth's. This atmospheric blanket, combined with its unique chemical makeup, makes it a fascinating laboratory for studying how life might emerge in conditions radically different from those on our home planet. What makes this story even more compelling is that we're on the verge of a new chapter in Titan's exploration. As we speak, scientists are preparing ambitious missions to uncover more of its secrets. Each new discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? Join me on this incredible journey as we explore the mysteries of Titan, where every revelation challenges our understanding of life itself, and where the impossible becomes possible. This is more than just a story about a distant moon. It's a tale that might forever change how we see our place in the cosmos. This remarkable world awaits us, with its methane seas, organic-rich atmosphere, and the tantalizing possibility of exotic life forms. Are you ready to discover what secrets Titan holds? Let's begin our adventure into one of the most fascinating worlds in our solar system. Let's take a moment to truly appreciate just how remarkable Titan really is. Here's something that might surprise you. This moon is absolutely massive. In fact, if you were to place Titan next to Mercury, our solar system's smallest planet, Titan would actually tower over it. And it's so large that it's nearly the same size as Mars. Just imagine, we're talking about a moon that rivals planets in size. But Titan's size isn't even its most impressive feature. What really sets it apart is something truly unique. It's the only moon in our entire solar system that has a thick, dense atmosphere. Think about that for a moment. Out of all the more than 200 moons we've discovered in our cosmic neighborhood, only Titan has this characteristic that we typically associate with planets. Speaking of its atmosphere, here's another fascinating detail. If you were standing on Titan's surface, you'd feel more pressure than you do here on Earth. The surface pressure there is 1.5 times what we experience on our home planet. It's as if you were about 15 feet underwater in a swimming pool. Now, you might want to pack your warmest coat if you're planning a trip to Titan because the temperature there is, well, extremely cold would be an understatement. We're talking about negative 179 degrees Celsius. That's so cold that methane, which is normally a gas on Earth, actually becomes a liquid and forms lakes and seas on Titan's surface. The story of Titan's discovery takes us back to a fascinating time in human history. It was the year 1655, and a young Dutch astronomer named Cassini Huygens was peering through his telescope when he spotted something extraordinary, a bright point of light near Saturn. This discovery was groundbreaking for its time, especially considering the relatively simple telescopes available in the 17th century. Huygens couldn't have known then that he had just discovered what would become one of the most intriguing objects in our solar system. What's particularly interesting about Huygens' discovery is that he made it using a telescope he designed himself. He was known for his innovative improvements to telescope design, which allowed him to see further and clearer than many of his contemporaries. In fact, the telescope he used to discover Titan was considered state-of-the-art for its time, with a focal length of 12 feet. Quite impressive for the 1650s. Today we've learned so much more about Titan than Huygens could have ever imagined. But each new discovery seems to make this moon even more fascinating. It's a world that continues to surprise us, challenging our understanding of what's possible in our solar system and beyond. Would you believe that despite being so incredibly cold, Titan is in many ways one of the most Earth-like worlds we've found? Its atmosphere, its weather patterns, and its surface features all remind us of home, just with a dramatic alien twist that makes it uniquely captivating. The story of how we came to know Titan's secrets is one of humanity's greatest space adventures. It all began with an ambitious mission named Cassini Huygens, a spacecraft that would revolutionize our understanding of Saturn and its mysterious moons. Imagine dedicating 13 years of your life to exploring a distant world. That's exactly what the Cassini spacecraft did. Launched in 1997, this intrepid explorer spent more than a decade dancing through Saturn's rings and studying its collection of moons. But among all its targets, Titan held a special place in the mission's heart. One of the most dramatic chapters in this story unfolded on January 14, 2005. On that historic day, a small probe named Huygens, named after Titan's discoverer, separated from Cassini and began its descent through Titan's thick orange haze. As it plunged through the atmosphere, Huygens became our first emissary to touch the surface of a moon in the outer solar system. The descent itself was nothing short of breathtaking. For 2.5 hours, Huygens transmitted data back to Earth as it floated down through Titan's atmosphere. Scientists around the world held their breath, waiting for each piece of information. Would the probe survive? What would it find? The anticipation was electric. Then something remarkable happened. Huygens didn't just survive its landing, it thrived. The probe sent back the first ever images from the surface of this alien world. What we saw left scientists speechless. Rounded pebbles scattered across the ground, evidence that this spot had once been the site of a liquid methane river. It was like finding a familiar landscape in an utterly alien setting. The discoveries kept coming. Cassini's radar pierced through Titan's thick clouds, revealing a world that looked surprisingly like Earth, with one crucial difference. Instead of water, liquid methane carved valleys, filled lakes, and formed seas. The largest of these seas, called Krakenmeer, is larger than Earth's Caspian Sea. Perhaps one of the most fascinating findings was the detection of complex organic molecules in Titan's atmosphere. These chemicals rained down from the sky, creating a unique environment that some scientists think might be similar to Earth before life emerged. It's like looking back in time at our own planet's past. But the mission wasn't without its dramatic moments. There were tense times when communication was lost, moments when the spacecraft had to navigate through potentially dangerous regions, and countless instances where scientists had to make split-second decisions that could make or break the mission. The grand finale came in 2017, when Cassini, running low on fuel, made its final plunge into Saturn's atmosphere. It was a bittersweet moment for the scientific community, like saying goodbye to an old friend who had shown us wonders we never imagined possible. The legacy of Cassini Huygens lives on in every new discovery about Titan. Its 13-year mission transformed our understanding of this fascinating moon from a mysterious orange dot in our telescopes to a world that, in many ways, mirrors our own Earth, albeit with its own unique and fascinating twist. Thanks to this incredible mission, we now know that Titan isn't just another moon. It's a world that continues to captivate our imagination and challenge our understanding of what's possible in our cosmic neighborhood. When we talk about alien worlds, nothing in our solar system quite matches the strange beauty of Titan. This extraordinary moon boasts an environment so unique yet strangely familiar that scientists often find themselves doing a double take when studying its features. Imagine stepping onto Titan's surface. Above you stretches a thick, hazy atmosphere, predominantly nitrogen, just like Earth's, but with a much higher concentration. This dense atmospheric blanket is tinged with an orange-brown color from complex organic molecules suspended in the air. It's so thick that if you were standing on Titan, the pressure pushing against your body would be about 1.5 times what you feel on Earth. The sky would never be blue, instead, perpetually shrouded in. But what truly makes Titan remarkable is its complex organic chemistry. The atmosphere is a vast chemical factory, where ultraviolet light triggers reaction. These reactions create a cocktail of organic compounds, the building blocks of life. Some scientists have called Titan a prebiotic Earth, frozen in time, potentially showing us what our own planet might have looked like billions of years ago before life emerged. Perhaps the most fascinating parallel to Earth is Titan's methane cycle. Just as water cycles through Earth's environment, evaporating, forming clouds, raining down, and flowing across the surface, methane does the same on Titan. At Titan's frigid temperature of -179 degrees Celsius, methane can exist as a gas, a liquid, and even a solid. Clouds of methane form in the atmosphere, methane rain falls to the surface, and methane rivers carve channels into the icy landscape before flowing into vast lakes and seas. It's Earth's water cycle played out with an entirely different substance. The landscape below is astonishingly diverse. Radar images from the Cassini spacecraft revealed seas and lakes of liquid methane and ethane, primarily clustered around the northern polar region. The largest, called Kraken Mare, is larger than the Caspian Sea on Earth. Elsewhere, vast fields of dunes stretch across equatorial regions, made not of sand but of tiny grains of organic material, essentially frozen hydrocarbon snowflakes. Mountains of water ice rise from the surface, and impact craters dot the terrain, though fewer than we might expect because Titan's thick atmosphere burns up smaller meteorites before they can reach the ground. And beneath all this, perhaps Titan's most tantalizing secret, a global subsurface ocean of liquid water mixed with ammonia. This hidden ocean, sandwiched between layers of ice, could potentially harbor the conditions for life as we recognize it, while the surface offers the possibility of something entirely different, perhaps methane-based life forms with biochemistry unlike anything we've ever imagined. If you're fascinated by what you're learning about Titan, hit that like button and tell us in the comments. What kind of life do you think could exist in Titan's methane lakes? Subscribe to our channel, Exploring the Universe, for more mind-expanding journeys through our cosmic neighborhood. When we think about finding life beyond Earth, our imagination often jumps to planets with liquid water, moderate temperatures, and atmospheres rich in oxygen. But what if we've been limiting ourselves? What if life could evolve using completely different chemistry than what we're familiar with? This is where Titan becomes truly mind-blowing. The organic richness of Titan is extraordinary. Even before the Cassini mission, scientists knew Titan's atmosphere contained complex organic molecules. But when the Huygens probe descended through those orange clouds in 2005, it detected a stunning array of compounds, tholins, hydrocarbons, nitriles, the very chemical building blocks from which life on Earth emerged. These aren't just simple molecules. We're talking about complex carbon chains that, on Earth, would be considered the precursors to amino acids and nucleotides, the foundation of life as we know it. But here's where things get truly fascinating. What if life doesn't need water at all? On Titan, liquid methane and ethane might serve the role that water does on Earth. Think about it. These lakes and seas provide a liquid environment where molecules could meet, interact, and potentially form more complex structures. In fact, some scientists have theorized about methane-based life that could use the liquid hydrocarbons as a solvent instead of water. The chemistry would work differently, of course. Water is polar, allowing it to dissolve salts and create the ionic environment that Earth biochemistry relies on. Methane is non-polar, meaning different types of compounds would dissolve in it. But this doesn't make life impossible, just different. Some researchers have suggested that life in such environments might use structures similar to lipid membranes, but composed of molecules better suited to methane solvents. These hypothetical organisms might breathe hydrogen instead of oxygen, eat acetylene instead of glucose, and produce methane as a waste product rather than carbon dioxide. This isn't just wild speculation. Laboratory experiments have already shown that certain types of membranes can self-assemble in liquid methane at Titan's temperatures. The chemistry is possible. Different, alien, but possible. What makes Titan even more intriguing is how it resembles early Earth. 4 billion years ago, our planet had little to no oxygen in its atmosphere. Instead, it was rich in methane, nitrogen, and carbon dioxide. Not identical to Titan, but with some striking similarities. By studying Titan today, we might catch a glimpse of the conditions that existed on Earth when life first emerged here. It's like having a time machine to Earth's distant past. And let's not forget that Titan might host not just one but two potential environments for life. While the surface lakes of methane offer one possibility, that deep subsurface ocean of liquid water and ammonia provides another, more familiar environment where life might exist. Two completely different biochemistries could potentially evolve on the same world. Perhaps the most humbling aspect of studying Titan's astrobiological potential is how it forces us to expand our definition of life itself. We've spent centuries defining biology based on Earth's example: carbon-based, water-dependent, oxygen-breathing. But the universe is vast and strange, and life, if it exists elsewhere, might be equally vast and strange in its diversity. Titan challenges us to broaden our imagination and ask, what other ways might the cosmos have found to create living systems? As Carl Sagan once said, we've only just begun to explore the cosmic shoreline, and Titan, with its alien lakes and organic-rich atmosphere, represents one of the most promising uncharted territories in our search for life beyond Earth. The exploration of Titan is about to enter a revolutionary new phase that will transform our understanding of this mysterious world. After the groundbreaking discoveries of the Cassini Huygens mission, scientists have been eagerly planning the next chapter in our exploration of Saturn's largest moon. The star of this new era is NASA's ambitious Dragonfly mission, scheduled to launch in 2027. But this isn't just any spacecraft. Dragonfly represents one of the most audacious exploration vehicles ever designed. Imagine a nuclear-powered drone the size of a small car, specially engineered to fly through Titan's dense atmosphere. This remarkable rotorcraft will become the first vehicle to fly its entire science payload to multiple locations on any celestial body, giving us unprecedented mobility in our exploration of another world. What makes Dragonfly truly extraordinary is how perfectly suited it is for Titan's environment. The Moon's atmosphere is 4 times denser than Earth's, while its gravity is only about 14% of what we experience here. These conditions make Titan the ideal place for aerial exploration. It's actually easier to fly on Titan than on Earth. The drone will be able to travel tens of miles in a single flight, covering more distance in hours than Mars rovers have traveled in years. The primary goal of Dragonfly is nothing less than the search for the building blocks of life. Titan's surface is rich with complex organic materials that have been interacting with liquid water for potentially thousands of years. This chemical playground might contain the very ingredients that sparked life on early Earth. By sampling materials from different regions, scientists hope to understand how far prebiotic chemistry has progressed on this alien world. One of the most fascinating targets for Dragonfly is the Selk impact crater region, which has been selected as the initial landing site. Why is this area so special? Impact craters are particularly intriguing to astrobiologists because they represent locations where energy was suddenly introduced into the system. In this case, melting Titan's icy crust and potentially creating a temporary liquid water environment where complex chemistry could flourish. The Selk crater shows evidence that liquid water and complex organic materials existed together for thousands of years, a recipe that might be perfect for the emergence of life. From this starting point, Dragonfly will embark on a journey across Titan's equatorial regions, visiting diverse landscapes including dune fields that harbor carbon-rich materials. These dunes aren't made of sand like on Earth. They're composed of tiny grains of frozen hydrocarbons that have fallen from the atmosphere like cosmic snow over millions of years. What discoveries might await us? Scientists expect to find increasingly complex organic molecules, perhaps even structures that resemble the membranes of living cells. They'll analyze the chemical composition of Titan's surface materials in unprecedented detail, measure atmospheric conditions across different regions, and map the Moon's geology with high-resolution cameras. But perhaps the most tantalizing possibility is that Dragonfly might find evidence of methane-based life, organisms completely unlike anything on Earth that use liquid methane as a solvent instead of water. Such a discovery would revolutionize our understanding of what life can be and dramatically expand our search parameters for life elsewhere in the universe. What's particularly moving about the Dragonfly mission is that it represents humanity's growing ambition in space exploration. Just decades ago, landing a small probe on Titan seemed like science fiction. Now we're sending a nuclear-powered drone to fly across its surface and conduct sophisticated scientific experiments. Each mission builds upon the knowledge gained from previous explorations, pushing the boundaries of what's possible and bringing us closer to answering one of humanity's most profound questions. Are we alone in the universe? As Dragonfly soars above Titan's alien landscape in the 2030s, it will send back images and data that will captivate the imagination of people around the world, just as the first images from the Huygens probe did nearly 2 decades earlier. And who knows what wonders this mechanical dragonfly might discover as it buzzes across the skies of this strange and fascinating world. When we think about life on Earth, we take for granted the cozy conditions that allowed it to flourish. Comfortable temperatures, liquid water oceans, and abundant energy from the sun. But life on Titan? That's a whole different story. A challenge that would make even the most extreme organisms on Earth shudder. Let's start with the most obvious obstacle. The bone-chilling cold. Titan's surface temperature hovers around -179 degrees Celsius. That's cold enough to freeze oxygen solid. At these temperatures, chemical reactions that happen in seconds on Earth might take centuries on Titan. Imagine trying to digest your breakfast, but it takes longer than your entire lifetime. This extreme cold fundamentally changes how chemistry works, slowing down reactions to a glacial pace. But here's where things get truly fascinating. Despite these frigid conditions, Titan actually maintains liquid on its surface, not water, but lakes and seas of liquid methane and ethane. This presents one of the most intriguing challenges for potential life, using a completely different solvent than water. Water has been called life's universal solvent, for good reason. Its unique properties allow it to dissolve the complex molecules necessary for life as we know it. But on Titan, any life forms would need to use liquid methane or ethane instead. This isn't just a simple substitution. It's like trying to bake a cake using motor oil instead of water. The entire recipe of life would need to be rewritten from scratch. Some scientists have proposed fascinating theories about how this might work. Methane-based life could potentially use structures similar to cell membranes, but composed of complex molecules called azotosomes that remain stable in liquid methane. These hypothetical cells might absorb certain types of hydrocarbon molecules from their surroundings and release others, creating a completely alien biochemistry. Then there's the energy problem. Life needs energy to function, and on Earth, most of that energy ultimately comes from sunlight. But Titan receives about 1% of the sunlight that Earth does. How could life power itself in such a dim environment? Some scientists propose that potential organisms might harness the chemical energy from the reaction between hydrogen and acetylene, which are both present on Titan. It would be like life running on a kind of natural rocket fuel. Another possibility involves tapping into temperature differences between Titan's surface and atmosphere, or even utilizing static electricity generated in Titan's hydrocarbon-rich environment. Just imagine. Creatures that essentially power themselves through the same static electricity that makes your hair stand up when you rub a balloon on it. The metabolic pathways for Titan life would be completely different from what we see on Earth. Our biology is based on carbon compounds dissolved in water, with reactions involving oxygen. But on Titan, metabolisms might involve nitrogen-based compounds in liquid methane, with hydrogen playing the role that oxygen does in our biology. These alien biochemical processes would be unrecognizable to Earth's life forms, a completely different operating system for living things. Perhaps the most profound challenge is time. Evolution on Earth has had over 4 billion years to work its magic, starting from simple molecules and developing into the complex web of life we see today. But chemical reactions on Titan happen at a much slower pace due to the extreme cold. Processes that might take days on Earth could take thousands of years on Titan. This raises a fascinating possibility. If life exists on Titan, it might be evolving in extreme slow motion. Generations could span centuries or millennia, rather than days or years. A Titan organism might perceive our entire human civilization as a brief flash, here and gone in what would seem like an instant to them. There's a beautiful analogy that puts this in perspective. If Earth life is like a hummingbird, fast-moving, warm, and requiring constant energy, then Titan life might be more like a glacier, cold, slow-moving, but persistent over vast stretches of time. Both are valid approaches to the challenge of existence, just operating at radically different tempos. The quest to understand potential life on Titan isn't just about finding aliens. It's about expanding our understanding of what life itself can be. It forces us to question our assumptions about biology and consider possibilities we never imagined. And in doing so, it reconnects us with the wonder and mystery that has always driven scientific exploration. As we contemplate these extraordinary challenges, we're reminded that life, wherever it might exist, is a testament to the incredible adaptability and persistence of the natural world. Whether in the warm oceans of Earth or the frigid methane seas of Titan, the possibility of life finding a way continues to inspire our journey of discovery. Did you know that Titan's atmosphere is so incredibly thick that you can actually see it from Earth with a decent telescope? Unlike our moon or most others in the solar system, Titan doesn't appear as just a plain sphere. It has this beautiful orange haze surrounding it. This atmospheric cloak is so substantial that when astronomers first observed it, they were absolutely stunned by how much it resembles what early Earth might have looked like billions of years ago. And speaking of time, imagine experiencing a season that lasts 7 Earth years. That's right. When winter comes to Titan, it settles in for what would be 7 complete years on our planet. Picture this. A child born at the beginning of Titan's summer would be heading to 2nd grade by the time autumn finally arrived. These extended seasons create weather patterns that move in slow motion compared to Earth, with methane rainstorms and changing shorelines of hydrocarbon lakes that shift over decades rather than days. There's something wonderfully whimsical about Titan, too. Scientists have chosen to name its surface features after enchanted places from literature and mythology across human cultures. As you travel across this distant moon, you'd find yourself visiting regions like Shangri-La, Xanadu, and Aztlan, magical lands from stories and legends. It's as if we're mapping a fantasy realm, except this one is very real, just extraordinarily distant. The upcoming Dragonfly mission might be one of the most exciting developments in space exploration of our time. This remarkable spacecraft will be the first rotorcraft ever to fly on another world. Imagine this, a drone-like vehicle with 8 rotors, about the size of a small car, buzzing above the surface of Titan, sampling different locations miles apart. The gravity is lower and the atmosphere is thicker than Earth's, making flight actually easier there despite the extreme cold. Dragonfly will hop across the landscape, studying sites that would be impossible to reach with a traditional rover. And here's something truly fascinating. Scientists aren't just speculating about Titan's conditions, they're recreating them right here on Earth. In specialized laboratories, researchers have built what they call Titan chambers, sealed environments where they precisely match the temperature, pressure, and chemical composition of Titan's atmosphere and surface. Inside these chambers, they can watch how organic compounds behave, how methane rain might fall, and even test how potential life processes might function in such an alien environment. It's like having a little piece of Saturn's mysterious moon right here on our planet, helping us prepare for what we might discover when we finally get to explore it up close. When we talk about Titan, we're really exploring the frontier of what we know about potential life beyond Earth. Let's hear what the leading minds in this field have to say about this fascinating moon. Dr. Sarah Hurst, one of the world's foremost experts on Titan's atmosphere, describes it as a natural laboratory for studying organic chemistry on a planetary scale. She once told me something that still gives me chills. The chemistry happening in Titan's atmosphere right now might be similar to what was happening on Earth billions of years ago before life emerged here. Imagine that. We might be witnessing in real time the same chemical processes that eventually led to our existence playing out on a moon nearly 1 billion miles away. The upcoming Dragonfly mission has generated tremendous excitement in the scientific community. Dr. Elizabeth Turtle, who leads this groundbreaking mission, explains it with infectious enthusiasm. Dragonfly isn't just another spacecraft. It's a mobile laboratory that will taste Titan's chemistry in multiple locations. She believes the mission could revolutionize our understanding of prebiotic chemistry. The compounds we're looking for on Titan are the building blocks that could lead to life, and Dragonfly will give us our first chance to directly sample and analyze them in their natural environment. What's particularly exciting, she notes, is that Titan provides us access to complex organic materials that have been cooking in a natural laboratory for millions of years. But how would we actually detect life if it exists on Titan? This question sparks heated debates among astrobiologists. Some scientists argue we should look for specific organic patterns that could only be produced by living organisms. Others suggest we need entirely new detection methods since Titan's life might use completely different biochemical processes than anything on Earth. As one researcher puts it, we might need to redefine what we're looking for because we're limited by our Earth-centric imagination of what constitutes evidence of life. The latest research on alternative biochemistries has opened up fascinating possibilities. Scientists have recently demonstrated that cell membrane-like structures can form in liquid methane at Titan's temperatures, something previously thought impossible. Others have shown that hydrogen-breathing microbes could potentially survive in Titan's environment, using acetylene as food. These discoveries are pushing the boundaries of what we consider possible for life, suggesting nature might be far more creative than we've given it credit for. Now, let's get interactive and imagine what it would take for you to survive on Titan. First, you'd need extreme cold protection. We're talking about temperatures around -300 degrees Fahrenheit. Your spacesuit would need to be unlike anything we've designed before, with multiple insulation layers and internal heating systems. You'd also need oxygen, of course, since Titan's atmosphere, while thick, is mostly nitrogen with no oxygen to breathe. But here's the upside. The atmospheric pressure is slightly higher than Earth's, which means your suit wouldn't need to be pressurized like it would for the Moon or Mars. And get this, you could potentially fly on Titan. The combination of low gravity and dense atmosphere means that with wing attachments, a human could theoretically fly under their own power. Imagine that adventure. Earth life forms would need extraordinary adaptations to survive on Titan. Any organism would need to completely reimagine its biochemistry to function in liquid methane instead of water. Cell membranes as we know them would freeze solid, so life would need alternative structures, perhaps made of compounds called azotosomes, which researchers believe could remain flexible in Titan's frigid lakes. Metabolism would need to operate at incredibly slow rates due to the cold, perhaps taking advantage of the small amounts of hydrogen and acetylene available as energy sources. Evolution on Titan would likely produce creatures that process information and grow at timescales we'd find painfully slow, perhaps taking centuries to show changes that would happen in days on Earth. So what might a methane-based organism actually look like? Scientists speculate that Titan life might resemble delicate, balloon-like structures floating in the methane lakes, with thin membranes that maximize surface area for absorbing nutrients. Others imagine something more like living crystals, with intricate geometric patterns that can store and process information while remaining stable in extreme cold. These organisms might communicate through chemical signals that spread through the lakes, creating invisible networks of information exchange. Their movements would likely be slow and deliberate, conserving precious energy in an environment where every chemical reaction comes at a high cost. Perhaps most alien to our understanding, these life forms might perceive their world through senses completely unknown to Earth biology, detecting subtle electrical changes, pressure waves, or chemical gradients that would be entirely imperceptible to human senses. The possibilities are as vast as the distance between our worlds, and that's what makes Titan one of the most compelling destinations in our search for life beyond Earth. What we discover there might forever change our understanding of what it means to be alive in this universe. When we look up at the night sky and see Saturn's rings glowing, it's hard to imagine that one of its moons might hold the key to understanding our own existence. Our journey to understand Titan isn't just about exploring another world. It's about understanding our own story, our origins, and our place in the cosmos. Think about this. Every discovery we make on Titan gives us a window into what Earth might have looked like billions of years ago, before life as we know it emerged. The complex organic chemistry happening in Titan's atmosphere today mirrors what might have been happening in Earth's primordial soup. By studying Titan, we're essentially time-traveling to our planet's distant past. But the implications of finding life on Titan would be absolutely revolutionary. If we discover even the simplest forms of life using methane instead of water, it would completely transform our understanding of what's possible. It would tell us that life isn't just a rare accident that happened once on Earth, but rather a cosmic imperative that can emerge under vastly different conditions. The future of human exploration on Titan is equally fascinating. While we won't be walking on its surface anytime soon given the extreme cold of -179 degrees Celsius, our robotic explorers are becoming more sophisticated. The upcoming Dragonfly mission, for instance, will be the first time we fly a rotorcraft on another world. Imagine controlling a drone on a moon hundreds of millions of miles away. It sounds like science fiction, but it's becoming reality. The technology we're developing to study Titan is already changing life here on Earth. The advanced cameras designed to peer through Titan's thick atmosphere are now being used to improve medical imaging. The autonomous navigation systems being developed for Dragonfly could revolutionize everything from delivery drones to self-driving cars. Even the materials science needed to protect instruments from Titan's extreme cold is finding applications in our everyday world. Perhaps most importantly, Titan reminds us that we're part of something much bigger. Every time we learn something new about this fascinating moon, we're not just adding to our scientific knowledge, we're writing another chapter in humanity's greatest adventure, our quest to understand if we're alone in the cosmos. By studying places like Titan, we're not just reaching for the stars, we're reaching for answers to questions that humans have been asking since we first looked up at the night sky. This isn't just space exploration. It's a journey of self-discovery that could redefine our understanding of life itself and our place in the universe. And who knows, maybe someday, the discoveries we make on Titan will help us recognize life on distant exoplanets, opening up even more possibilities for understanding our cosmic neighborhood. As our journey through the mysteries of Titan comes to an end, we're left with a profound sense of wonder. This extraordinary moon, with its lakes of liquid methane, its thick orange atmosphere, and its rain of hydrocarbons, shows us just how creative the universe can be. Just imagine, on this distant world, where temperatures plunge so low that water turns as hard as steel, we might find answers to questions that have puzzled humanity since we first gazed at the stars. Every detail we uncover about Titan challenges our assumptions about what's possible in our cosmic backyard. You know, it's fascinating to think that when Cassini Huygens first spotted Titan through his telescope in 1655, he could never have imagined the incredible world we now know it to be. From those first glimpses as a mere dot of light, to the Huygens probe's historic descent through its atmosphere, to our upcoming Dragonfly mission, each chapter in Titan's exploration has brought new surprises. As we stand on the brink of potentially discovering life in forms we've never imagined, Titan reminds us that the universe is not only stranger than we imagine, it's stranger than we can imagine. This mysterious moon might just hold the key to understanding how unique, or how common, life might be in the cosmos. And speaking of exploration, we're just getting started. The next chapter in Titan's story is about to unfold, and you won't want to miss it. Join our community of space enthusiasts here at Exploring the Universe by hitting that subscribe button and turning on notifications. Together, we'll continue to unravel the mysteries of Saturn's enigmatic moon and witness humanity's greatest discoveries as they happen. Remember, every time you look up at the night sky and spot Saturn's golden glow, somewhere out there orbiting that ringed giant is a world that might completely change our understanding of life itself. And that's the true beauty of space exploration. It reminds us that there's always more to discover, more to learn, and more to imagine. Thank you for joining me on this journey through one of the solar system's most fascinating worlds. Until next time, keep looking up, keep wondering, and keep exploring the universe.